to this very special lecture. This is the 30th anniversary of the holiday lecture, and it is really my privilege to share this special occasion with you today. I promise you a good time, and you'll enjoy what we're going to share with you today, especially if you pay close attention. This being the 30th anniversary of the holiday lecture, we normally mark 30th anniversaries by using pearls. But in chemistry, we're going to mark this anniversary by using element number 30. That's zinc. Zinc is element number 30 in the periodic table. And zinc is a substance that is common in our daily lives. We have many examples. This adjustable elbow, for example, is galvanized iron. It means it has zinc in it. We have zinc products. We have zinc products in body care, health products. We have them as dietary supplements. And the food that we eat, meat, for example, has zinc in it. We're going to learn not only about zinc today, but about a lot of other different types of chemicals. Now, I've been fortunate in the past 30 years to have been associated with many, many very fine people in my lab and in my classroom and in my community. And at this time, I would like you to welcome one of my former graduate students who now works for the City of Madison Health Department, Mary Ellen Teston. Would you please welcome Mary Ellen? Hi, Mary Ellen. Welcome.
Thank you. Thank you for inviting me back to your lab.
I'm happy to see you again.
Well, in honor of the 30th anniversary, the zinc anniversary, I wanted to give you a little something.
Oh, peanut butter. So peanut butter has zinc in it too. That's yum.
Good for you.
Yes.
Well, in public health, as you know, we work with a lot of different kinds of experiments. One of the things we work with is water, drinking water, groundwater, and we look for metals in it. And the way we look for metals is by emission. And emission is not only very useful, but it's beautiful, like that. It's more beautiful if the lights are out. Could we have the lights down, please? This, Bassam, do you know what this is?
Oh, it's a beautiful green color.
And what's green?
Well, I would suspect it's boron of some sort.
You're right. This is boric acid.
Boric acid,
Isn't that nice?
Yes.
And in honor of the Rose Bowl, we also have a nice red color.
Yeah, beautiful.
And that's lithium. Anybody like yellow? Fans of yellow? This I love this.
Sprinkles of yellow.
Another very important relative of zincs, iron. That was iron. And this last one, who likes purple?
That's beautiful.
So
this is how you analyze for metals then, by using emission
spectroscopy.
Spectroscopy, that's
Yes.
what it's called, yes. And you use instruments.
Instruments that measure what the color is exactly and how bright it is.
Well,
We do it every day in the lab.
Very colorful. Thank you very much, Mary
Thank you for
Ellen.
inviting me to see.
Thank you very much. Well, I'm getting a little thirsty here, and I'd like someone to bring me out a drink of some sort, if possible. Oh, yes.
Here you go, Bassam, some orange juice.
Oh, but I really wanted something with raspberry in it, or strawberry, or something like that.
I kind of thought you were going to say that.
Wow. I'd like everyone to meet my longtime friend, Mr. Ron Perkins. I want to tell you a lot of things about Ron, but before I do that, I want Ron to explain to us what happened here.
Well, for your drink, I mixed some laundry detergent, some baking soda, and some acid like vinegar.
Yes.
And I used to experiment when I was a boy with those three things, and then I had some food coloring, and in this case I had an indicator. So they can do this at home.
People can do this experiment at home. They need laundry detergent, food coloring,
and baking soda,
and vinegar. In fact, we have this experiment on the Science is Fun website, and invite all of you to look at the website. not only for directions for this experiment, but for many other experiments too.
Right.
Well, I've known Ron for a long, long time, and I want to say something to you about Ron. Ron is the most outstanding high school teacher in the country, in my opinion. I want you to know it's a special treat for me, Ron, that you came from Connecticut to be with me on this 30th anniversary.
Well, this is a very special occasion.
Oh, yeah. And brought me throat lozenges, Dr. Zinc.
Dr. Zinc.
They have zinc in them, yes. Thank you, Ron.
You know, I have some experiments to show you. Would you
All
like
right.
to see them?
Yes, I'd love to.
You know, a long time ago, my uncle, Merle Perkins, who teaches here at the University of Wisconsin in the language department, sent me a chemistry set. I was in 3rd grade. Unfortunately, it said I couldn't use it until I was in 6th grade. But you know, that's what got me interested in chemistry, the most interesting of all subjects. And I remember in my chemistry set taking colorless clear solutions and mixing them together and coming out with remarkable things. This remains my favorite reaction. 2 colorless clear liquids making this gold yellow solution. And so I can't explain it even to this day how that happens. But you know, people have been coming to audiences like this for a couple of hundred years, Bassam. In fact, back in 1836, a Professor Scoffrin took a whole bunch of youngsters down by the lakeside in England, and he taught them about the solubility of ammonia in water. In this flask, I have a flask filled with ammonia. This is a gas that's very, very soluble in water. This is water that I've colored green, just so it will show up more. Professor Scoffrin, back in 1836, said, remove the stopper, and that was to show that there's no vacuum in here. And then he said, place the vessel below the surface of the water, and nothing happens. But that's because ammonia dissolves in water, and it's less dense, so it stays on the top surface. He says you have to slosh it. And so watch what happens when I slosh it. Whoa! I mean, ammonia certainly is soluble in water, Bassam.
Yes, indeed.
It's so much fun. Do you mind if I do it again?
Oh, please do.
Okay.
Please do.
Okay. Whoa! And lastly, Bassam, I would like to show you a demonstration that I learned from my students. You can learn a lot from students if you listen. And this is a demonstration on chemiluminescence. I'm going to mix together 2 solutions, and let's see what happens when we mix these 2 solutions together. And the lights will probably be coming down very shortly. Ooh.
That's pretty.
Yeah, that's why Scoffrin said chemistry is a science full of interest, wonder, and beauty. And then we're missing one other color, and these 3 colors, when mixed together, give us white light. Now, I had a student that said, do you think if we mix these solutions together, you'll actually get white light? And Bassam, I need you to help me. We're going to pour them down here.
All
We're going to pour them down together.
Okay.
So you get the green one, and I'll take the blue and the red one. And now we'll start pouring them slowly down. Yeah, that's what the student, my student was a little bit surprised. He was expecting white light. But you know what? Most of us at this point would throw away the solution, said experiment failed, let's go on to another one. But instead, this student did something very, very special. this student took a white cloth and he put it in to the solution and he said, maybe it's a red solution and maybe it really is giving off white light. And so he went a step further than you normally do, and guess what? He was right. This does give off white light.
Well, Ron, thank you very much for coming all the way here.
Thank you.
And sharing these experiments with us. Thank you, Ron. At this time, I'd like you to welcome the latest person to join my lab. That is Mr. Kurt Herman. Kurt? Welcome.
Hello. Hello. Happy 30th anniversary.
Well, thank you, Kurt.
I thought it would be kind of neat to make a blue color for everybody to see.
A blue color.
A blue color.
All right.
So what I have here is a chemical to add to this beaker to make a blue color.
He's new. You did say blue, didn't you?
I said blue doesn't seem to be working, and
No.
you mentioned that I was new. Well, this reaction is sort of new, too. A lot of new things these days require a battery to work. You wouldn't happen to have a battery laying around from earlier?
Yeah, I have
that we
batteries.
can,
Yeah, we have batteries in my
throw in
lab.
here and see if it works.
Sure. Would you like to use this one?
I'll try this one. Let me put it in there.
You dumped it in there.
Just dumped it right in. And I don't know if you can see that yet, but it looks like my solution is starting to turn blue.
Wow. That's a different use
A
for battery.
battery-operated chemical reaction. There's a blue color.
Well, that's very nice. That's impressive, Kurt. But you know what?
What's that?
I'd like to get my battery back.
You want your battery back?
Yeah.
Okay, well, I got an empty beaker right here.
All right.
Let's see if I can get your battery back.
Wait a minute. What happened to the blue color?
It appears that the blue color went away when we poured the battery out of there.
It's an elusive blue color.
But I think the blue color is hiding. So I have a little red cloth that I was going to use to wave at the television at the Rose Bowl. I can't go to California. But I think this cloth will be able to soak up this blue color. So let me give that a try here.
Oh, that's beautiful, Kurt.
So here's a blue color for everybody to see. I made a blue color today.
Yeah, but Kurt, this is, yeah.
Thank you.
Very nice. That's very nice, Kurt, and impressive. But you know, this is the University of Wisconsin, and our color is red.
That's right.
And we would like to have the red color
Okay,
back.
so everyone want the red color back. Okay.
Right.
We'll put it in here, see if I can get the red color back. But furthermore, I think my blue color is still hanging out somewhere. So let's wring out the blue color in this beaker and see if I can get a blue color.
My goodness. That's very special, Kurt. Thank you very much, Kurt. Thank you.
Thank you.
Thanks. All right, now I'm going to do an experiment at this end of the lecture table where I have in front of me 5 beakers that have in them clear and colorless liquids, and I'm going to line up behind them 5 flasks that have in them some not so clear liquids, and I'm going to mix the contents of the back row flasks with what's in the front row beakers. I'm going to do it this way, all right? You watch and see. I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 and a half. Oh, there it is. All right, one more. We'll give ourselves one more chance, all right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Almost, right. This is an example of what we call a clock reaction. And if all the concentrations, all the amounts of the ingredients are the same, and the temperature is the same, and all the other conditions are the same, then the appearance of the color occurs in the same time interval. We keep track of time by using a time device, not by counting, because when we counted, you and I were counting, we changed our cadence. Otherwise, the color would have appeared at the very same count if we counted at the same rate all the time. This color that you see is the color of potato starch that's been added to what we call the iodine clock reaction. There's some iodine in there, combines with the potato starch, and produces that color. Now to do the next experiment, which is down here, I'm going to get out a motor and get out a big beaker. This beaker, I want everybody to look at this beaker. Look at this beaker. This beaker has a volume of 4 liters. If you look at this beaker, you just learned how big 4 liters is. And you cannot unlearn it. You may forget it. That's different. And this beaker is empty except, yeah, you think about it. This beaker is empty except for, I'm going to put a magnet that's been coated with Teflon in there. I'm going to turn the stirrer on, the motor on, turn the light on like this, slow it down a little bit, all right, like so. And then I'm going to reach down here and get some clear and colorless liquids that I'm going to add to that beaker in sequence. So here's the first liquid, clear and colorless. And by the time it ends down there, it's not so clear anymore, but it is colorless. Here's the second one. Anything exciting happening so far? Not really, yeah. The volume has changed, you know. That's a big deal. We know that from everyday life, right? Oh, we add the third liquid here, and we watch and see. Is there anything happening now? Do you see anything happening? I don't see anything happening. How come I don't see anything happening? I'm not looking. What's the big deal about looking? The last time I looked, the color of the liquid in the beaker was blue. Right? You tell me when to look, all right? Shall I look right now? Right this second? Yes? Yes or no? No? Yes? You've got to help me out. Tell me when to look. Shall I look right now? Right this second. You sure? Sure. You look at it right now? Right now. It's blue. Every time I look at it, it's blue. Come on, you've got to give me better help than that, right? Right this second? Right now. I don't want to trip over anything. You sure with me now? It's blue. Oh, I'm going to go over to this side. Maybe this side can help me better, right? Right now. Bucky, right now. Right this second. No. Look at blue. Every time I look at it, it's blue, right? I heard someone say, look all the time. That's what you were doing, and I wasn't doing it. And I want you to remember that. When you do experiments, you always have to be on the lookout and be watchful for the very beautiful and complex transformations and changes that might be happening. Otherwise, you miss out on a lot of interesting and fun things that might be occurring. All right. This is what we call a chemical oscillating reaction. It has some of the same ingredients as the clock reaction, except that one of the ingredients gets consumed and then gets regenerated. That's why it oscillates this way, unlike the clock reaction that we looked at before. Now to do the next experiment, I'm going to come in the front and use this step stool to stand up. And I'll tell you what I'm going to do before I do it, and then we'll watch and see what happens when I do it. I'm going to take a match, and I'm going to light the match. This tube is a long glass tube. It looks like it's wet on the inside. That's because it has some water on the inside. But it also has in it some other gases that are colorless. We can't see them because they're colorless. And there's stopper. There's a rubber stopper up here, another one down there. So I'm going to take a match. I'm going to strike the match, remove the rubber stopper, and drop the match in the dark. All right? So I'll take this. Ready?
You scared me.
people who have seen this before call this the ghost of Christmas past. No, it isn't, no. What I'd like you to do now is to take a look at this very same reaction in slow motion. You won't hear the sound. You see the match coming up. There it is. I'm getting out of the way. And that is one way by which, yes, thank you. One way by which we learn more about different chemical systems is to watch them in slow motion and try to slow down the occurrence of the experiment so we can learn more about it. Now I'd like you to meet the chemistry demonstrator at the University of Wisconsin in Madison, and that is Dr. Kristen Johnson. Kristen? Make some room for you here.
Well, thank you.
You're welcome.
Well, I've seen that you've been mixing a lot of different chemicals today, and I thought I'd like to show you a chemical reaction that I like to do. And we've got a kind of a clear, mostly little brown solution in here, another clear solution in here. And I'm going to pour this in here and mix it up. And you can see right away it turns black, but I really want to mix this up well. So I'm just going to shake it real well like this. And you'll start seeing a reaction happening. Can you see any change happening in the solution?
It's changing color.
It's changing color. It's actually becoming silvery like a mirror. Can you see yourselves in that?
Yes, I can too.
Do you like that?
Yes, very much. So this is the season for making ornaments like this. And
Yes,
of course.
and if you see them around town, you'll know where they're made.
Yes, right here, by Kristen in my lab, right?
Yeah. And of course, in the lab here, we like to do things on a really big scale. So I also made this.
Wow, thank you very much, Kristen. Really
welcome.
appreciate this. Thank you. All right, we're going to now do some more experiments with, what am I holding here? Am I holding the balloons? Where are the balloons? The balloons are up in the air. What's holding the balloons up in the air? Well, strings are holding the balloons up there, right? What do these balloons have in them? They could have helium. That's a gas lighter than air, right? And that's a gas also that does not burn. So if I were to put a flame to the balloon, then I will discover whether or not there is helium gas in there. There are other gases that are lighter than air that burn. And so one way to find out what's in the balloons is to put the flame to them. Here we go. Are you ready? All right. Well, that balloon didn't have helium in it. That balloon had hydrogen in it, right? It had hydrogen in it, and that balloon, the hydrogen in that balloon combined with the oxygen from the air and caused that explosion to happen. So let's try this next balloon here. Now, some of you are covering your ears. Why are you covering your ears? Because you learned that there's sound energy being released in addition to the light energy. So let's try this one and see. Whoops. That sounded like a dud, right? That's because it had helium in it. Now, what we're going to do is try this third balloon, but I will tell you this third balloon has in it a mixture of hydrogen and oxygen. More oxygen in it than is in the air. And so I would like everyone to protect your ears from sound, potential sound damage by taking both fingers, sticking your fingers in the ear like this, okay? Well, I can't do that and do the experiment at the same time, so I brought with me some earplugs. So I'm going to put the earplugs on, and I want you to be protecting your ears. If you can hear the sound of my voice, that means you don't have your ears well protected. I can see that you're smiling because I can't hear you. So protect your ears very well as we now do our grand finale. Here we go. Thank you all very much for coming. Thank you very much. Thank you very much for joining us. Thank you. Thank you. Thank you very much.
you.